Hello everyone, I'm Bradley Sward, and this is my day 23 solution to the Advent of Code 2024 competition. The problem is called LAN Party, and basically as always here I am solving the problem in Python. So we have a network connection, we have all these computers networked together, and basically this is this is a couple of computers working together, but we're trying to figure out, at least for part one, how many thruples are there, how many networks of three computers are all networked together, A to B, B to C, and A to C is all, so they have like a triad here. And in this case here, for the sample data, 12 of them are such of those cases. And then from there, the question is, well, how many of them have at least one computer that starts with a T? That's just the problem. So we figured it out. In this case, 12 becomes 7. And in my case, I get 1,238 computers that have that. Or yeah. So find the sets, right? So there's 1,238 sets of three computers that work out. And so for my problem, reducing this down here for part one, here's my code that makes this work. Let me start running it. So generating the map is relatively simple. So in this case, even though I can never get this thing to work just right when I want it. I am mousing over it. I don't understand. I don't understand it. Anyway, okay, so there. So there's 520 computers in my network, and it turns out that there's 13 computers in every one of them. It's weird. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 computers that are connected to each computer, so it's basically a 14 sum, if you want to think of it that way, when it comes to this map. And so what I'm basically doing here is, this is the part that takes forever, at least relatively speaking, is because I'm taking my 520 computers by my 520 computers by my 520 computers, and I'm generating 140 million different possibilities to see basically, well, are these things available in the map? And I know, of course, I could simplify this, but this was a relatively simple problem compared to some of these others when it comes to the data set involved. So I'm like, well, let's do 140,000 of these, and let's test to see how many of these possibilities have a T that have at least one of the letters, right? Or. And so this is what takes a while. I can start running it now that it's going, and you can see that the numbers, this is how big is this set as I'm going, and I sort this as I go, because then I make sure I don't try this 6 times over, because ABC is different than ACB, which is different than CBA, and all those other nonsenses. So this reduces the amount of search in this part by 6 if I sort this and then I create a set of these values. So this will take a little while, but anyway, so this is the hard part, because I don't have anything to make this more efficient. Next year when they do this, show this again, I will look into how to do that. But for right now, I am good to go. So once this is all set, well, then all I'm doing is looking through, and I forget, I actually don't know how many. This is the how many different values, 5 million or whatever it ends up being. But of all of those, I go through all of that and I just check to see, is A in B, and is A in C, and is B in C, and and again, because they're double-sided here, A can point to B and B can point to A. It doesn't so they both point, it's bi-directional when it comes to the graph we're setting up. And so if that's the case, then I add one to the pile, and then at the end of the day here I get my 1200, what is it, 1238 or whatever it is. And that will be my solution to part 1. So I can look at part 2 while those numbers run. And so now for part 2, and again, we will get the right answer here in a couple seconds, which is what, 1238, 1238. So for part 2, you're like, oh goodness gracious, you're like, well, okay, I have 140 million possibilities, and now we're talking subsets, and we're like, oh my goodness, right? So we're like, okay, if all the computers connected together, what is the largest? And this is definitely something that whoever runs Advent of Code, I got to learn their name for next year. Great job on everything as always. And just to say, like, well, what is the largest subset that everybody in that subset is connected to each other? So like in this case, it's going to be, it's either going to be a 1, it's going to, like if it's 2 computers hooked together, it's a 2. If it's 3 computers hooked together, it's, in this case, it's 4. It's like there's 6 of these things. And then, like, well, how do we work this out? And you're like, now coming back to this part of the code, you're like, goodness gracious, I haven't run this number to see what this is. If you tried every subset, every single subset, it's 2 to the, in my case, 520th power. And that is a very large number. We think that there are what, something like 10 to the 80th or 10 to the 85th power particles in the known universe. So we're generating many, many, many more subsets than are even remotely possible to test. So what are we doing here? But in this case, as we talked about earlier, well, it turns out that there are no more than 14 computers in any subset. So you're like, well, that reduces the problem greatly. So we reduce the problem down to that many as opposed to forget it, right? Like, geez Louise, right? So that's why this is just a brute force way to solve it, because I'm like, well, give me all 16,000 subsets, and I took this code from Stack Overflow, whoever, I looked up power set, and this gives me all of it. And again, there are many more efficient ways to do this, but that's not how I'm working it out here. And so then this code will run me part 2, and let's see, this one will take a while, I would bet. But because what I'm doing here is I'm running that, right? So there's 16,000 subsets to test for each of the each of the 5 million or whatever different combinations. Is it 5 million? No, that's not what I'm thinking. Oh, whatever. But you kind of get the point here. I already, whatever. This is day 23, and it's already the middle of January, and this has been exhausting. Trying to just fun, but exhausting, some of these problems. But anyway, so for part 2, I'm taking this and I'm just saying, like, well, I'm going through all the subsets, and I go, well, are you in, like, basically, is everyone in all of those subsets? And so which subset is the largest one? And it will generate, and it will keep the largest one, and then it will sort it, because it doesn't much matter once we get to the end here. The length is what matters. And again, whoever made the problem set it up so that there's exactly one subset that's the largest, as opposed to many that could tie at that value. But you do end up with a subset that has all 14 in them, as you can see from the problem. Oops, that's not it. From the problem here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, there's only 13. Never mind, I thought there were 14. But anyway, so there's only a subset of 13 here that gets me the answer using what we were talking about here. Let me pull up the code one more time. And so, but that's all this is saying, is like, get me every subset of those 14 values, 13 or 14 values, test out every one of them, and if you find out that subset everybody in there connects, if I find one that's bad, I kick out of it. And if I find a good one, then I check to see, is it longer than the previous one I found. And again, it's just a brute force method. And at the end of the day, and I'll stop the video when I see the solution there, if I don't while I'm talking, and I go, it will print out that, and again, they said in order from low to high, basically sorting that list and adding commas. So you take a comma, you join all of the elements together using those commas, and you end up with the solution to part 2. Alrighty, so that's what I've got going here. It should take just a little bit longer to solve this problem. It's not ridiculously long, but I'm ready to move on to the penultimate problem. I'm hearing things. I haven't seen anything. I haven't looked at any. I never look at anything until I've solved the problem. I'm hearing this 24 might be hard, but 21 was ridiculous and took me a week, during the holiday season. But we'll see about day 24. For those of you watching, thanks as always. Please comment if it matters to you about anything. Appreciate you guys watching, and I'll see you in the next video. This is taking longer than I thought it would. Should be coming any time now. Let's see, what is it generating? How much work now that I'm thinking about it? There's 2 to the 14th power. And there's 520 computers. And I have to try, on average, 7 against 7, 40, 50 times 25. On average, we'll just make it 40 by 40. Yeah, it has to do some math to figure it out. Quite a lot of computation. I can see but not see how subsets work here. I've heard rumors of there being something or other that needs to be solved just from the people commenting or just the post titles on Reddit. But I don't know per se. I don't want to just sit here making this thing run another 10 minutes. How much more is there to go? Let's see, I'm at computer TI. Where are you, TI? Where are you in the... Oh, I hate this. Oh, it's faster. Just let it run. I ran this downstairs on my better computer, so that's why I'm misinterpreting how long it takes to solve. Oopsie. Should be done any minute now. Any second now. Okay, so at this point, if I just click on whatever and I find something, or just click anywhere, the largest is BG. You can see there's BGBL. There is the answer, and it won't find anything better than that. Where are we in the list here? We're at computer VK. Where is that in the map? VK, do it your way. Are we anywhere close to the end? Oh no, we're not even, we're around here, right? So we got not too many more to go. We'll get there. But that is the solution to the problem. It's already there. Whoever's made it this far, you deserve a cookie. I don't have any cookies to give you, but you deserve one. Oh yeah, I'm doing hot lunch on Monday. What? I am doing hot lunch on Monday. Okay. I have it listed on my calendar. Does he talk to himself all the time? No. But dead air, whatever. Come on, computer. Solve the problem faster. Come up with better algorithms, Brad. There you go. There's BG, BL, blah, blah, blah. There's the answer. I can finally feel better about closing this thing off. Have a good one, everybody. Take care.